All right. How's everybody doing this morning? Okay. All right. You guys watched the Super Bowl yesterday? A little bit? Yeah. 49ers were doing really well there up until the end. Well. All right. So today we're going to start with a quick review of some of the things we talked about last time. So we talked a little bit about constants and servo motor control and functions. So we'll review those. And then today we're going to learn some more about programming. We're going to learn about communicating with a person using the serial terminal. We're going to learn about variables, and we'll also learn about multi-core programming. Okay? Morning. And with the lecture, I'm going to try something a little bit different today. I'm not just going to stand up here and talk to you about each of these topics. Instead, I'm going to kind of show you a program that we're trying to create, and then show you how we build up from there, and kind of explain how each one of these concepts helps us to make this program. Okay? So it'll be a little bit different format, but hopefully it will be engaging and interesting. And then we'll go on and do a preview of today's lab. So are there any questions before we get going? Okay, so last time we talked a little bit about constants. So constants are these numbers that you define early on in your program, and they can be really useful for things like defining a pin number. So say you want to control your left motor, and you know that that's connected to pin 16 right now. What you can do is right at the beginning of your program, you can say left motor pin equals 16, and then anywhere in your program where you want to talk to your left motor pin, you just put in the constant that you defined, left motor pin. So that way you say send pulses to left motor pin. And this does a couple things. First of all, it makes it easier for a person to read the program because it's immediately apparent where you're trying to send those pulses. You're not just sending them to a number, you're sending them to the left motor pin. And also, it makes it easier to maintain the code because if somewhere down the road you need to change the pin where that left motor is connected, you can easily go and just change that in one place in your program, and then the rest of your code automatically gets updated. So these constants are very helpful for those reasons. So but the thing about the constant is that you can only define it once. You set that number once at the beginning of your program, and then it's fixed for the rest of your program. Okay? So are there any questions about constants? All right. And then we talked a little bit about servo motor control. So we said that servo motors are these electric motors that have a little computer brain attached to them. And the way that they work is you send a message to that computer brain to tell it what you want the motor to do, and then that brain takes care of the low-level control of sending the right amount of voltage and current to that motor to make it actually do what you asked it. So the main thing that we need if we're going to interact with servo motors is we need to know the protocol that we use to talk to them. In other words, the language that motor understands. So we said that the protocol for talking with these hobby servo motors is to send voltage pulses. So if we're looking at a graph where you have voltage here and time here, then what we would see is we would see a low voltage, like 0 volts for a while, and then you would see a spike. And we call these spikes pulses. And what really matters is the pulse width. In other words, the amount of time that pulse lasts. So pulse width of 1 millisecond would be full speed clockwise, say. And 2 milliseconds would be what? Not quite. So 1 millisecond is full speed in this direction. Yeah, exactly. 2 milliseconds is full speed counterclockwise. So then 1.5 milliseconds would be right in the middle. And what does that mean? Stop. Exactly. And then other values in between give you other speeds between stopped and as fast as possible. So the closer you are to the middle, the slower you go. The closer you are to the ends, the faster you go. Okay? So that was the protocol that we used to send messages to the servo motors. So any questions about that? Okay. And then we also talked about functions last time. And we said a function is a little mini program within your larger program. And these functions can be useful for a number of different things. So the main purpose of a function is to encapsulate a little piece of code. In other words, wrap it up so that you can use it again and again. So for instance, last time we created 3 functions. Anybody remember what those functions were? We were controlling our robot, so what did we make it do?
Straight, right, left.
Yeah, straight, left, and right, exactly. So that way, anytime you want your robot to go straight, you can just call this go straight function, and you know that that already works. You don't have to type out all of those or put together all those blocks again. It's already tested. You know it's there. You can just use it. Okay. Same thing when you want to make it go left. You just put in the go left. And again, this saves time, but it also makes your code easier to read, because instead of having when you want the robot to go straight, you don't have to have this chunk of code in there that says pulse out pin 16 1 millisecond, pin 17 2 millisecond, all this complicated code. Instead, you can just have a little function block that says go straight. So when you come to that part in your program, it's really clear what you want your program to do. Okay. And that brings me to another thing about functions. The function itself is just wrapping up the code, but does the function run by itself when you make it? No. Once you wrap it up, you actually have to call it when you want to use it. So you make the function so that it can be used, and then when you want to actually use it, you have to call it somewhere in your program. Okay? And we'll talk about functions again today, so we'll go over that. So are there any questions about any of these things that we talked about last time? Okay, cool. So then let's go on to our main topic for today. And again, we're going to talk about serial communications, variables, and multi-core programming. But I'm not just going to stand up here and describe them. I want to actually show you how they work in a real program. Okay? So let's get to that. Okay. So what I'm going to do is I'm going to show you kind of what we want this program to do, and then we'll see how we can build it up. Okay? So if I run this program, let's see what happens. So this says the current blink time is 500 milliseconds. So it sounds like something is blinking. So let's go over here to our main camera, and we're looking down at our robot, and we can see that the little light down there is blinking. Okay? And the program said the blink time was 500 milliseconds. And that looks like it's blinking on for about half a second and off for about half a second. So it sounds like the program is describing what's going on right there. Okay? Now let's go back here. Now the program says, please enter a new pause length. So it's asking us if we want to, if we can enter a new number. So let's make that 1,000. So I put that in, and now it says the current blink time is 1,000 milliseconds. So let's go back here to our camera again. And we can see that that's blinking more slowly. So now it stays on for about a second and off for about a second. Okay? So we can actually we can update this blink time as we go. And it asks us to enter a new one. So if we make that, say, 300, and then we look over at that blinking light, when I hit enter, watch what happens. Enter. So now you can see that it's blinking much more quickly. Okay? So this program is asking me to tell it how long the blink time should be, and then I put in the amount of time that I want, and then the program automatically updates how fast that's blinking. Okay? So that's what our goal is in the lecture today. That's what we want to do. We want to make a program that can do this, that can make that light blink, and then allow the user to enter the amount of time that they want that light to blink for, or how long they want that light to stay on, and update that and go through that cycle over and over again. Okay? So that's our goal for our program today. So let's see how we can actually do that. Okay, so the first thing that we want to do is we want to make the light blink. So this is something we've done before, right? So let's see if we can remember that. So remember that light was attached to a particular pin. So we could say make pin 26 high. So that should be fine. Anyway, let's delete that and try this. Yeah. All right. So we make the pin high, and then we wait for a short time. So we go up here to control and then pause. So let's make that 500 to start with. And then we can make that pin low. So I could go through the menu again and find that and put that out again. But instead, I already have this this block on my diagram, so I can just right-click on here and say duplicate, and then change that to low, and then another pause. Okay. So if I do that, now I can run this program, and let's see what happens. So I run this program, and I saw one blink there. Okay? And that's what I expect. I expect to make the pin high, so it stays on for a little while, and then go low. So this is a good start. And this is really what I do when I'm writing a program. I start with something very, very simple and make sure that that works the way that I want, and then I just add on little pieces at a time. And that way, if I come and I add on a little piece and it works, it's great. I can go on to the next part. If I add on a little piece and it doesn't work, then I know that the problem was in that little piece of code that I just added. So if I'm looking for the problem, I have a really small area where I have to look through, okay? Makes it a lot easier to debug that. All right, so I've got this. I made it blink once. So if I wanted to make it blink forever, what could I do? Yeah, a repeat, yeah. So I can come up here to control and I say repeat forever. And I just put that around there. So now I can run that. And now it's blinking and it just keeps going forever. So cool. All right, so we're doing pretty well. Now there's a couple of improvements I'd like to make here. First of all, right now I'm just using a fixed number. And we said that that's not a good idea. What's better if I'm going to be sending messages to an LED? What's better than a fixed number there?
Constant.
A constant, exactly. So I can come up here to control, or values rather, and create a constant here. So I'll make this I'll call this LED pin, and I'll make that 26. And then down here, well, it doesn't let me specify a separate thing. So instead, I'll come here to pin states and I'll use this one instead. And then I'll go here to values, and I'll grab this one that says my value, and I'll make that LED pin. I'll delete that, and then, all right, so now I'm using this constant. So I'm going to make my LED pin high and my LED pin low. So I can run that and make sure that that still works. And it's running, and it's still making that LED blink, so that looks good. All right. Cool. Okay, so we made the LED blink. Now what I'd like to do is I'd like to communicate with the user. So what I'd like to do is I'd like to send a message to the user. So the way that I can do that is I can come over here to the communicate block. And I'm going to come here to where it says terminal. And then I can use this thing that says terminal print text, and then it'll show a message. So right now it just says the message hello. So let's see what happens when I run that. Communication lost. All right, let's try this again. Okay, so cool. So now it says the message hello, and it makes this light blink. So so that's cool. But now, remember, the goal is that I want to be able to tell the user how long that light is blinking for. Okay, so I want to have I want to have something that tells the user how long that pause actually lasts. And so what I could do is I could come here to serial terminal and say serial print number. So I could change this message. I could say the current blink time is, and then I could print a number. I could make this 500, because right now the blink time is 500. So I could say current blink time is 500. So let's see what happens when I do that. Okay, so that's cool. But now, what if somebody were to come in here and change this around? If they made that 250 and that one 250, they might forget to update it up here. Okay? So especially if this program got bigger, it's inconvenient if these things are separate. So it would be nice if we could just change this in one place and be able to set that to whatever we want and have it update everywhere automatically. And a way that we can do that is with something called a variable. So a variable is a way to, for the computer to store something in memory. Really, it's just a location. It's a name that we give a number that we're trying to remember. Okay? So we can use those by coming over here to this variable menu here. So I can create a new variable. I just click up here where it says new variable, and I'll call this one blink time. And I like to give myself a unit when I give myself a variable. So I'll call this blink time in milliseconds. Okay? So now I have this new variable called blink time in milliseconds. And so what I can do is now I can put this up at the beginning of my program, and I can give that a number. So I can say that that is 500. And now anytime that I want to refer to that blink time, I don't have to type in a specific number. Now I can use that variable. So down here, when I'm saying that the current blink time is something, now I don't have to use a specific number. Now I can replace that with a variable. So the way that I do that is I delete the fixed number, and I come back here to variables, and now you can see that there's this blink time millisecond variable. So I can grab that and plop that right in there. And then I can put that everywhere else in my program as well. So I can delete all the other instances where I had that hard-coded in, and then I can duplicate that, put that in. So now I can try and run my program again and make sure that it's still working. So now it's running, and you can see that that blink time is going, and it's staying on for about half a second. And if I come back here to my program and I make that 1 second, and I run that, now you can see that the blink is happening more slowly. Okay, it's staying on for 1 second. And I only had to update that at one spot in my program. Okay, so we're doing pretty well there. So any questions about that so far? Okay. Yeah.
Do you have to connect the constant and variables to your program like that stacked up? Like they have to be touching?
Oh. So what you want in this case, well, you always want to define your constants at the beginning of your program, because they're going to be used throughout the rest of your program. And in this case, I want to define my my variable at the beginning of the program. So the short answer is yes. And you want to have them at the top here. And the longer answer is yes, they should be stacked together at the top because you want them to happen first, and the things at the top of your program happen first. You always want things to happen in your program in a very predictable way, in a predictable order. So yeah, the best way to do that is to have them stacked up here at the very top of your program. Yeah. If you have your program kind of spread out like this, then what's going to happen is the computer is going to look at this, and it's going to look to try to figure out what's closest to the top of the screen. And it's going to do that part first.
Oh, interesting.
Yeah. So if I run this, again, it should work the same way. Let's see. Yeah, yeah, so it's still working, and that's fine. But things become a little tricky if your program gets kind of rearranged. So if it's over here, you know, this part is still happening first, but now if I put this up at the kind of above the other thing, let's see what happens. See if it still figures this out. Yeah, so now it says the current blink time is 0 because this thing happened first. It said the current blink time is, and it looked for this blink time, but that hadn't been defined yet. So it went in an order that you didn't really want. So yeah, so you want to have things stacked up like this to make it.
Constants coming through first with the variables, and then okay.
Exactly, yeah. Good question. All right. So, so this is great. We are now telling the user what the current blink time is, but really what we wanted is we also wanted the user to be able to define a blink time. Okay, so we wanted the user to be able to put in an amount of time that we want the LED to blink for. So the way that we can do that is we can come over here to terminal again, and we can say terminal receive a number and store it in item. So I'm going to grab that and put that under there. So yeah, so I'm going to receive a number, and it says store in. Now over here, this is where you can tell it a variable where you want to store that number. So I'm going to store that in this variable called blink time. So now we also want to kind of tell the user what's happening here. So I'm going to give us another message. We'll go here to terminal and then print more text. We're going to say, please enter a blink time. All right, so let's run this and see what happens. So if I run this, it says the current blink time is 1,000. Please enter a blink time. So I can type in, say, 500, and then hit enter. And now you can see that that LED is blinking, and it stays on for about half a second, and it goes off for about half a second. Okay. So that's working because we store this number in this variable called blink time, and then down here we use that variable when we're determining how long to make that LED go on and go off. So any questions about that? Okay, but there's a problem here. All right, let's try this again and see the problem here. So it says the current blink time is 1,000. Please enter a blink time. So I can type in 300, say. So now this is blinking fast. It stays on for 300 milliseconds. But what if I want to enter a new blink time? Right now, the terminal hasn't given me a new message. So it's not allowing me to enter a new blink time. All right? So that's a problem. So right now I can enter it once, but I'd like to be able to enter it over and over again and change it whenever I want. So that's a little bit of a problem. So let's go back here. Let's try and figure out what we can do to make this happen. So in the past, what we've done, if we want to repeat something, is we have put a control loop around it, right? We could say repeat forever, right? So so I can put a repeat loop around this these terminal commands. So let's run that and see what happens. So it says the blink time is 1,000. Please enter a new blink time. So I can type in 500. Okay, and great. It's given me a new a new line. It says now the blink time is 500. Please enter a new blink time. But does anybody see a problem with this? Yeah.
Yeah, it's not blinking.
It's not blinking. Yeah, that's the problem, right? I can type in all the blink times I want, and that's great, but the only problem is it's not actually blinking. Okay? So let's come back here and look at the code and figure out, so why is it not blinking? Yeah.
Because it keeps repeating the terminal.
Right, right. So this part up here, where I'm displaying the message, is in a repeat forever loop. So as soon as it gets down here, it comes back up to the top and then repeats. And it just stays in this part of the program forever, and it never gets down here to the actual blinking part. Okay? So that's an issue. So what we can do to fix this is that we can remember that the propeller here is actually a multi-core chip. So that means it can do multiple things at the same time. So we can take advantage of that. We can have one of the cores, one of the little processors, do this this communication with the user, while a separate processor does this blinking thing. Okay? So we can separate those tasks apart so that they can both be going on at the same time. So so the way that we do that is we make this blinking code into a function. So we'll come up here to functions, and we'll call that we'll call this function blink. And so remember, this now allows us to call this function whenever we want it. And when you make a function, you can tell that function to run in its own core. So we can tell this function to start and just start going by itself in its own core. And the way that we do that is that we come up here to control, and then down here it says new processor and function. So we can put this right up at the top of our program, and then in there we can call the function blink. So we can say, so when we do this, we're telling this propeller chip to run this function called blink in its own core. So that means that this little processor is going to be running this blink function forever. And so you might think that once it starts running forever, it's just going to keep on doing whatever it's doing, and so you might think that it would just keep blinking at the same rate forever. But we can, fortunately, in this function, every time that it runs, it uses this variable called blink time. So if that variable gets updated by any other function, this blink function will detect that change and will change itself. So now let's run this. So when we run this, we can see that now that that little LED is blinking, and that's a good thing. We know that it should be blinking because we started this blink function right at the beginning of our program. So it's already blinking. Now if we enter a blink time, say 300, now we've updated that variable, and so that blink function is using that new value in that variable, and it's changed itself. So now it's only staying on for 300 milliseconds. And we can update this as many times as we want. And since these two things are running at the same time, side by side, we can have them doing different things at the same time, and they can still communicate with each other using these variables. Okay, so this is really powerful. This is great for robotic control. Like, say for instance, if you wanted a robot arm to move at a certain speed, you could have one function that makes that robot arm just move, and then you could have another function that talks to the user and says, please enter a new robot arm speed. And then you could enter that speed, put it in a variable, and then that arm control function could update that speed as it goes. So it's really powerful to be able to do two different things at once and still communicate between them. Okay? So that's what I wanted to talk about in lecture today. So you can see we've talked a little bit about serial communications. That's what we're doing here. We're having the computer communicate to the user by displaying messages, and we're also having the user communicate to the computer by entering numbers that get stored in variables and used in our program. So we've done serial communication. We talked a little bit about variables and how they're useful for storing information, like these numbers, and how we can use them to communicate between different functions in a program. And then finally, we talked a little bit about multicore and how that could be very useful for doing 2 or 3, or in this case, there are 8 cores on this processor. So you can literally be doing up to 8 different tasks all at the same time. Okay? So multicore can be very, very helpful too. The last thing that I wanted to say is if you're going to do serial communication, that has to be on sort of the main core of the processor. So any other functions like motor control or light control or things like that, you can have them run in a new processor like this. But when you want to do serial communication, that one has to be in the main core. Okay? So that's really all I wanted to say about the lecture topics. So are there any questions about that? All right. Then let's go on and do a preview of today's lab. So we can find the lab under Canvas. So in the lab, you're going to be doing, you're going to write a few short programs that take advantage of some of these things that we talked about: serial communication, variables, and multi-core programming. So if we come here to assignments, it's here under multi-core programming, variable, and terminal. So at the beginning of the lab, there's a little bit of background here. And then the first program you're going to write makes 2 LEDs blink at different rates. So imagine you wanted to make one LED blink on and off every half a second and another one blink on and off every third of a second. Okay? It seems like a fairly simple task, but if you were to try to write that out in a traditional programming language, it could be a little bit complex. Fortunately, if you're doing it in a multi-core environment, it's really simple. You just write one function to make one light blink at half a second, another function to make a light blink on and off at a third of a second, and then run each of those in their own core. And then they're running side by side, and everything is easy. So that's the first thing you're going to do in your lab there. And then the second thing we're going to look at is variables. So we're going to do a little bit of math and put the result in a variable, and then later we're going to use that variable to make a light blink a certain number of times. Okay? So you'll try that, and then we'll do a little bit of serial communication. So you will display a message, and then finally, the last thing is you're going to kind of put some of these ideas together. So you're going to write a program that's going to ask the user, how many cheers do you want? And then the user will input the number of cheers that they want, and then your program will display that many cheers. So for instance, if the user said they wanted 3 cheers, then it would repeat this line, hip hip hooray, 3 times. Okay? So in order to do that, you have to use a couple of these ideas. You have to use the serial communication to display the message. You have to read a message from the user and store that in a variable, and then you have to use that variable to make a part of your program repeat a certain number of times. Okay? So you're kind of putting all those ideas together. So that'll be the last big challenge for today. And then when you're done with that, you can upload that program to Canvas. So are there any questions about the lab there? All right, cool. Then I'll take attendance, and then I'll let you go.